today's demonstrations are about sounds, another kooky idea I came up with, and the sounds I've got lined up for you, I'm hoping, is hiss, roar, pop, crack, perhaps a whistle, then a bang, and a woof. Now, I know we've got at least one person here who's allergic to sulphur. If you are allergic to sulphur, leave when I give you the warning before this one. I'm putting this one last. Okay, because that is sulphur. Okay, so we'll start off with a nice quiet noise. We'll start off with the hiss. This is one of my favourites. Some of you will have seen this one before. This is some nitrocellulose, or cellulose nitrate. I think one of those names is incorrect, but it's often used. So really what I've done is I've replaced the hydroxy groups, the OH groups, on the ends of the cellulose which make up this. This is medical gauze, which I took from the medical laboratory assistant program. And I replaced it with nitro groups, which are NO2 groups, which means that this particular cellulose contains an awful lot of available oxygen. We'll find that available oxygen is a big deal when we're dealing with the kinds of reactions which give sounds. So we'll see what happens when we burn it. So you may or may not have heard that. I certainly heard it. There was a good hiss sound there, and there's very little ash left over, and that's because there was plenty of oxygen. Usually in a combustion you're short of oxygen because there's only 20% oxygen in air. So you often run out of oxygen, which gives you incomplete combustion, and carbon monoxide form instead of carbon dioxide. So you get a lot of soot. In this particular case there wasn't a lot of soot because there was plenty of oxygen. So that's our hiss. Let's try a roar. I may be exaggerating when I say roar. We have someone with a propane allergy in the building, so I'm using a methane burner, not a methane, methanol burner instead. I haven't tried this with a methanol burner before, so it might not get hot enough. We will try it. This is ammonium dichromate. Ammonium dichromate has a tendency to decompose, and when it does so, it produces quite a lot of gases and quite a voluminous solid, which is chromium oxide. You see that's pretty much burned out now. So it did get hot. Leave that down there for the moment. So that's our roar. Did anyone... It wasn't very roary, I have to admit, but it's the best I could come up with. The next one, I'm fairly sure, is going to give us the sound we're looking for. This one I made a few days ago. It's ammonium periodate, and again some of you would have seen this before in previous demonstrations. The cool thing about this one is it will make no noise, no noise, no noise, no noise, and then suddenly quite a loud pop, which always makes me jump. So if you see me jump, don't be surprised. Okay, so I'm going to heat this up.
There we go.
You may have seen me flinch a bit. You notice one of the products is purple, iodine. The iodine is in the molecular structure. This is the equation here, NH4IO4, and you see we get a lot of gases out of it very suddenly. And the iodine is originally produced as a gas but quickly becomes a solid. And if you look at the test tube now, the purple colour is almost completely gone. Alright, so that brings us on to the next one, which is over in this fume hood in the corner. Some of you would have seen this one before. Ni3NH3, which is commonly referred to as nitrogen triiodylate, is a shock-sensitive explosive. As you make it using ammonia in water, and it starts off as fairly stable, but as it dries out it gets less and less stable. And the balancing trick is that if it gets unstable enough, dry enough, it will eventually explode just under its own weight. So you have to prepare this just enough time in advance so it's dry enough to make it go off, but not so dry that it goes off on its own. So I think I've succeeded this time, and I'm going to bash it with a stick to see if I can make it go off. Okay, so watch for a big cloud of purple gas at this time, because this one also contains iodine. So you see that the purple gas is dispersed now, but it was there briefly. Sorry if I'm afraid. And it contains about 2 litres of hydrogen. Now, in theory, when I light the top of this, it might whistle for a while and burn a bit like a candle as the hydrogen burns out the top and draws in some air from underneath. And eventually, when the hydrogen reaches a perfect mixture with the oxygen in the air, we should see an explosion. However, every time I've done this so far, it's exploded immediately. So, be prepared for both. I'm going to put in my hearing protection because I'm very close to it. The rest of you, I strongly recommend you put your fingers in your ears when I put the lighted splint towards the top of this. Okay, because it can actually hurt your ears. So I, in fact, rather than strongly recommend, I'm going to insist you put your fingers in your ears.
No, he's done.
You don't have to do it yet. As soon as this flame goes over there, that's when it's needed. Okay? So I'm going to take off the bottom stopper. Hydrogen is lighter than air, so it probably won't be coming out yet.
Can you tell us when the plugger is?
Sorry?
Can you tell us when the plugger is?
Yeah, I will, yeah. Okay, you need your fingers in your ears now. Come on. So that was actually one of the best ones I've had so far. I'm quite pleased with that. Just a shame it's not whistling. I'll sort that out for next year. Okay, so the next demonstration and the final one, this is the one involving sulfur. So anybody with a known sulfur allergy, please leave now. You have been warned. Okay, so in this cylinder we have a mixture of N2O, which is laughing gas, and CS2, which is carbon disulfide, and it really stinks. And what I'm going to do is throw a lighted splint in, and as this reaction is going, by the way, I'm not entirely sure of this reaction, I may have the wrong equation here, but it's something very similar to this, and there may be side reactions as well. But as these gases are produced, they compress the gases underneath the gases that are burning. So we get a wave of burning on the way down, and they compress the gases beneath them, and that causes the whole tube to resonate, and you get a very woof kind of sound. We'll also see a very bright blue flash, which was my excuse for doing it last time. Okay, so this is the final one. This one can be loud, but won't require fingers in ears.
That was definitely fast.
Hey, really good.
It produces sulfur dioxide something. It's got straight in it. Cut that down.
That's the crack, yeah.
There we go. So that's all the noises. Hiss, roar, pop, crack, whistle, bang, woof. Minus the whistle.